Kinematics is examining or looking at a body or an object's motion, and biomechanics involves both kinetics and kinematics. Kinetics is where forces are involved in the movement of an object or body. So this could be linear, which a linear motion is in a straight line. Curvilinear motion is obviously in a curve. Angular, or in other words rotational motion, is around an axis, is movement around an axis. General motion is linear and angular motion together, so movement in a straight line and movement around an axis together. So for linear it could be force, gravity, mass and weight, whereas for angular is torque, not sure how to say that word, moments and levers. Projectile is an object in motion within the air. There are three things that affect the flight path of an object. So this could be how much force is put onto or applied to the object, where the object is hit or the point of force onto the object, and the direction of force. Numerical models are created by looking at elite players, research through literature or online, and comparing to yourself your own model to the perfect model. Are numerical models useful? You need to know the technology, which can be quite complicated, which makes it quite difficult, so you have to be experienced with it. It's only really used for elite performers or universities because it's quite expensive. It lacks ecological validity because it's done in a lab, so it's not that useful to like a basketball situation. Labs can bring lots of validity because they use the correct measurements and the correct tests, and they probably have the best equipment. However, the scores change between jumps. It is quite time consuming. It needs to be a sports scientist to understand what's happening and what the data means. It's better and more applicable to elite performers. You can track your change in your performance levels with it, and you can decide whether physiology or technology is needed to help you improve. So the 5 effects of force are rest of motion. So this would be jumping up to get the ball from a tip off in basketball, because you're steady and not moving before the ball's put up, and then once it's up you'll go from that rest to motion to hit the ball back. Change direction, so dribbling around an opponent. Accelerate, so sprinting back to catch an attacker to stop them having an effort on the basket or having a shot. Deaccelerate, so once you've sprinted into position, if someone passes you the ball, you need to slow down so that you can stop when you've got the ball, as you're not allowed to move with the ball in basketball, and you can then either pick out a pass or have a shot yourself. Change in shape, so in the box out rebound you go from a low ready position to a tall and quite wide position quite quickly, so that would be useful in basketball. Newton's first law of motion. This is called inertia, which is a reluctance to change. So everybody at rest or moving with constant velocity in a straight line will continue in that state unless acted upon by an external or an unbalanced force exerted upon it. It's the official definition. So there's balanced forces, so they are equal in opposite directions. There is absolutely no acceleration. Net force there is no net force, so the net force is equal to 0. And there's the motion, it doesn't differ at all. So if forces are balanced, then acceleration will be 0 meters per second squared. So then objects at rest and objects in motions will both have a velocity of 0 meters per second, but objects at rest stay at rest, and objects of motion also stay in motion. So that's if the forces are balanced, whereas if the forces are unbalanced, then there will be an acceleration. And what the acceleration is based directly from what the net force is, or the acceleration is based inversely on the object's mass. So there can be a balanced force in motion, which equals a zero net force, a constant velocity or speed, and there's definitely not. And if there's no unbalanced external force, then there definitely won't be a change of motion. Newton's second law of motion. This is known as the law of force and acceleration. So the acceleration that an object has or produces because of their net force is directly proportional to what the net force is. So it will go in the same direction as the net force, and it will be inversely proportional to the object's mass. The size and the direction of the force is based on what the acceleration is. So for unbalanced forces, you could have jumping up for a layup in basketball, as one force would be larger than the other. And then you could have sprinting to win a rebound off the hoop. So acceleration would be in the direction of the larger force. There would be a change in the state of motion. Inertial mass is, so F, force is needed to overcome the inertial mass and create motion. Force equals ma, so force equals mass times acceleration. So mass is usually the same value in sport, because people are a similar mass, or the equipment is. So you calculate the force or acceleration of objects rather than the mass. So acceleration is calculated by changing the equation to A equals F divided by M. So for example, if you pass a basketball to your teammate and the basketball weighs 0.9 kilograms and it accelerates at 12 meters per second, then you would do 0.9 times 12, which would give you a force of 10.8 newtons. Newton's third law, action and reaction. So, to every action there is an equal and opposite reaction. So, it is a reactive force. For example, when a basketballer or player pushes down into the ground, that is action, and then when they push back up to shoot the ball from a free throw, it creates a reaction, and then they can shoot the basketball because they've come back up. So the action force on the tip off is when the basketball hits your hand, and the reaction force is when your hand pushes the ball to one side or down or wherever the ball goes. A basketball taking a free throw, the performer applies a force to the basketball, and the basketball applies a force back on the player's hands of an equal magnitude but opposite in direction. This is because the basketball player is heavier than the basketball. The basketball is driven or pushed forward. Another example for Newton's second law of motion is that how fast the basketball travels when he passes the ball to a teammate or shoots the basketball is based on the amount of force applied to the basketball by his muscles. So the more force that he applied to the basketball when he shoots, the faster the basketball would travel to the hoop, or the faster it would travel to a teammate if he was passing it. Momentum. Momentum is a tendency that a moving object has to carry on moving once it's started to be in motion. So this is linked to Newton's first law. Is the amount of motion a moving object contains, and it comes from mass and velocity. So the equation is change in momentum equals mass in kilograms times velocity, ms minus 1. it is measured in kilograms per meter per second. So, for example, a basketball player's mass is 100 kilograms and they are dribbling the ball at 4 meters per second minus 1 equals, so the answer would be 400 kilograms meters per second minus 1, as it is 100 times 4. Another example would be if the player's mass is 120 kg and they're sprinting back to try and steal the ball off an opponent at 7 meters per second, then the answer would be 840 meters per second would be their momentum. Impulse. Impulse is just another way to describe force. So the amount of time a force is placed or pushed against an object or body is related to the change in momentum which takes place because of this. So this is what an impulse does. Is force times time is the equation to get impulse. So for example, if a basketball player passes a ball with a force of 10 newtons to a ball for 0.4 seconds, the impulse would be 4 newton seconds. And if a basketball player applies a force of 30 newtons to a ball for 0.3 seconds, their impulse would be 9 newton seconds. Stability. Mass is how material and object, the amount of material an object is made up of. The center of mass is when the body is completely balanced in every single area or direction. So you have a line of gravity through the middle of your body that goes down, and the gravity acts down through the center of mass. So, for example, when you're shooting a basketball, the center of mass is by your abdominals just above the leg that's in the air. So when force is applied through the center of mass and there's linear motion, you need a good center of mass so you don't slightly lean to one side and then shoot wide. Stability is linked to how difficult or hard it would be to move a body when it's in a balanced position. The wider your base of support is, the more stability that you'll have. So there are some things that can help you to increase stability. So if your center of mass isn't as high, or you can make your center of mass lower, which means that your line of gravity is inside of your base of support. So therefore you can make your base of support as wide as possible, and there's more points of contact. So to do the box out rebound, you need stability to stop the opposition being able to easily push you out the way and get the ball. So therefore you want a lower center of mass to get a bigger base of support. So you can create instability by moving your center of mass outside of your base of support, because your weight will go to one side and cause you to topple. A basketball player will need to do this when they're trying to block an opponent's shot, so that they can make themselves bigger and block more shots if they want to lean to one side. But they need to be careful they don't do it too much and fall over. The 2D imaging is just off your phone on a tripod, and therefore it will just capture the body and you doing the pushing down on the force plates and not in too much detail, so you won't be able to directly look at the joints, and it has to be slowed right down. Whereas Vicon is 3D imaging and allows you to get a motion capture and really look into detail at the player's joint angles and movement, as the image just shows you like the lines of their body, the outline of their body, so it's much easier to see the angle at joints, for example. However, this is quite expensive and would only really be used by elite performers. So the force plates measure force, the camera measured movement, and whereas Vicon measures the force and the amount of movement. So we did the counter movement jump, which is standing, then you